Hello, this is Math 2231 coming to you from the College of DuPage during the summer of 2020. And this is a continuation of the lecture called Calculating Indefinite. When I left you, you were working on this problem. I'll give you a little bit more time. You know what to do. Now let's see how you did. So here is our problem. U equals 2 minus cosine 1 minus x. Du equals minus sine 1 minus x dx. dx equal du over minus sine 1 minus x. Doing the substitution, we get, magic happens, the sine 1 minus x cancels, and I get minus the indefinite integral u to the fourth du. It's going to be minus 1/5 u to the fifth plus c, and I back substitute, and that is our final answer. This next problem we had was this one. U equal sine of 3z. Du equal 3 cosine 3z dz, and dz equal du over 3 cosine 3z. Magic happens. I pull the 1/3 out of the integral, and this is equal to 1/3 the integral of u to the 10th du. That's going to be u to the 11th over 11 plus c, and this is our final answer when I reverse the substitution for u. Here was the problem we were confronted with. Our substitution is u equal 3 minus tangent of 4t. du is going to be minus 4, the chain rule, secant squared 4t dt, or dt is equal to du over minus 4 secant squared of 4t. When I make this substitution, the secant squared 4t cancels, so magic happens. I pull the 1/4 through the integral, and I have minus 1/4 the integral of u cubed du. That's going to be minus 1 over 16 u to the fourth plus c, and then I reverse the substitution for my final answer. Here are 3 more for you to do. Now they look similar, but they're different. You know what to do. Let's see how you did. So to do this problem, what we should do is just let u equal 5y plus 4. du is going to be this, and dy is going to be this. So I pull the 3 and the 5 out of the integral for 3/5, and that's the integral of 1 over u du. So it's 3/5 ln absolute value of u plus c, and then I reverse the substitution. This is our final answer. This problem is somewhat different. U is equal to 5y squared plus 4. du is then 10y dy, and dy is going to be du over 10y. The y's cancel, so magic happens. The 3 is pulled out, and the 1 over 10 is pulled out for 3 over 10. And again, this is the integral of 1 over u du. That's going to be the logarithm, but this time it is 3 over 10 ln absolute 5y squared plus 4 plus c. This is the next problem. Again, it looks similar, but there's some differences. The same substitution is going to be used, but this time, instead of getting what I got before, I'm going to get u to the minus 2 with the same substitution. So I add 1 to the exponent, divide by the new exponent, I get this, and then I reverse my substitution, getting this, and it can be written this way. This next problem is different yet again. We're going to exploit this integral formula. The integral of 1 over 1 plus u squared du is going to be the arctangent of u plus c. So that's what we're working to, because we have no y in the numerator. So first thing we're going to do is factor a 4 out of the denominator, and see, I'm trying to make this look like u squared plus 1. And then it is something plus 1, so I make that u squared plus 1. I pull the 3 over 4 out of the integral, and I have this. And that motivates our substitution. U is equal to square root of 5 over 2 y, or dy is equal to 2 over square root of 5 du. So what we're going to do is substitute that in to our equation, pull out the 2 over the square root of 5 from the integral, and we get this. That's going to be this constant times the arctangent of u plus c, and when I reverse my substitution for u, this is what I get for my answer. Here's 4 more problems for you to calculate, so please you know what to do. Let's see how you did. So this is going to be our substitution, and dt is going to be du over 2 times that. We make the substitution. We have 1 over u cubed, that's u to the minus 3. Add 1 to the exponent, divide by the new exponent, and I get this as my answer when I reverse the substitution. The next one is similar but different. This is u, and this is dt again. But when I make the substitution, I have 1 over u. That's going to be the natural logarithm of the absolute value of u, and I reverse my substitution, and this is my answer. The last example we have, this is u, this is du, so dx is du over minus 8x. I make the substitution, pull out the minus 1/8, and I have the integral of u to the minus 1/2 du. Add 1 to the exponent, divide by the new exponent. Reverse my substitution, and this is the final answer. The last example here, we're going to exploit the formula that we have of the indefinite integral of 1 over the square root of 1 minus u squared du is the arc sine of u plus c. So I have to make this look like that, and so this is 1 minus 2x whole squared dx, meaning that this is my substitution, dx being 1/2 of du. So I make that substitution, pull out the 1/2, this then is the inverse sine of u plus c, and I reverse my substitution, and this is my final answer. See you in 32.2.